Hello dear students, welcome back to our school, to our chemistry sessions. Don't miss your time, I miss you so much, and quickly let's start again. We firstly must make a quick revision on what we have studied. We studied that many trials for the classification of elements were made, firstly by the scientist Mendeleev, who tried to classify the elements according to their atomic mass, but he failed. Then Moseley come after that and classify the elements according to the atomic number, and they fit well with the properties. So comes the periodic law, which states that the physical and chemical properties are functions of the atomic number. And we'll continue with the modern periodic table, in which the elements are classified also according to their properties and the atomic number. So what is the modern periodic table? The modern periodic table is the arrangement of elements in order of their atomic numbers, so that elements with similar properties fall in the same column or group. Why these elements are similar properties and why they are in the same column, that's we will see after a while. Now, periods and blocks of the periodic table. Elements are arranged vertically. Vertically means from up to down in columns in the periodic table in groups. So the columns are called groups that are similar chemical properties, while elements are also organized horizontally in rows or periods. Horizontally in rows or periods. So the horizontal rows are called periods. Don't forget this. Groups means columns, rows means periods. Now, first we'll see what is the modern periodic table. As you can see in the modern periodic table, there are how many groups? Let's count together. How many groups? Groups means vertical groups from up to down, means columns. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. We have 18 columns or 18 groups in the modern periodic table. And what about the periods? Let's count horizontally in the rows. Now we have 1, 2, 3, 4, 5, 6, 7. So we have 7 periods. So the modern periodic table have 18 groups and 7 periods. Someone may ask, what are these? These are two series which are called Lanthanides and Actinides. Their correct place are inside the table, within the table, here and here. From 57 to 71 atomic number comes the Lanthanide series, and in the pink one from 89 to 103, the second series, which is called Actinide series, its right place is here. But why we put them here? Because they have different properties and different blocks, as we will see. Now, the periodic table is divided into 4 blocks: the S, P, D, and F blocks, and these are the names or the symbols given to the atomic sub-levels. The atomic sub-levels. Now we want to see where's P, D, and F block. Return back to the periodic table. The S block are the first 2 groups. Column 1 and column 2 are the S block. The middle, which has the orange color here, are called the D block. And from group 13 to group 18 are P block, and those Lanthanides and Actinide series are F block. So the modern periodic table: S, P, D in the middle, and F below the table. So now we know the symbols and the blocks of the periodic table. We'll start each block and the elements found in it. Let's first start with these 2 columns or these 2 groups, group 1 and group 2. What does group 1 mean? Group 1 mean all the elements in the group 1 will have 1 electron in their outer level, and group 2 means all these elements which are in blue color will have 2 electrons in their outer level. Group 13 means 3 electrons in the outer level, 14 4 electrons in the outer level, and so on. So now we'll start with group 1 and group 2. Group 1 starts from hydrogen to francium, but as you can see, hydrogen has a different color than the other elements. Why? Because hydrogen has a unique properties. It's not similar to the elements in its group. It can act as metal or non-metal according to the conditions of the reaction. So hydrogen has its own group. It's not belonging to the elements of the group 1 in their properties nor in other groups. It has a unique properties. So let's start with this group 1. Group 1 are called, elements of group 1 are called the alkali metals. Alkali metals. Why they are called so? Because they found one. When any elements of this group react with the water, they form alkaline solution. Alkaline means basic solution. Basic solution. But this group 2, this group which is in blue, are called alkaline earth elements. So group 1 alkali metals and group 2 alkaline earth metals. What the difference between group 1 and group 2? Group 1 are most active metals, are more active than group 2. They have only 1 electron in their last level, so they can lose this electron easily during the chemical reaction. So they are very, very active metals. Comes after them group 2, which is also metal. Group 2 elements all are metals, but they are less active than group 1 elements. So group 1 and group 2 all are metals, but group 1 are more active than group 2. Group 1 and group 2 belongs, as we said that before, they belongs to the S block. So group 1 and group 2 S block. Now comes to the middle of the table. Here the elements which are colored in orange, these elements are in the middle of the table. They start to appear from period 4, from row number 4. They are called the transition metals. Transition metals or D block elements. D block elements or transition metals. They are also metals, but they have different electron configuration than group 1 and group 2. They have different properties, different characteristics. They are metals, but they are not active as group 1 or group 2. In the right side of the periodic table, you can see from group 13 to group 17, these are the non-metals or the P block elements. P block elements or the non-metals. And the most active non-metals are group 17, which is called the halogen elements. The halogen elements are the elements here in red. In group 17 starts with fluorine to statine, and this is the last one, and the element which has a symbol TS is artificially made in the laboratories. And this in pale blue, these 6 elements in pale blue, or 7 actually, they are the metalloids or semi-metals. They can behave as metals or non-metals. And the last group in the modern periodic table is the inert gas group or the noble gas group, which are group 18. They are inactive, or to be accurate, they have low reactivity. They don't make any reactions. Even no, they can make reaction. Actually, helium can make reaction, to be honest. Helium can make reaction, but under certain conditions. So to be accurate, we said that they have low reactivity, not inactive. They have low reactivity. So these are the modern periodic table, and don't forget the Lanthanides and Actinides series below the table. They are both below the tables. They are F block elements. Now we say that the elements of group 1 of the periodic table are known as the alkali metals, which are lithium, sodium, potassium, rubidium, cesium, and francium. In their pure state, all of the alkali metals have silvery appearance because they are metals. Silver appearance. All the metals have silver appearance and are soft enough to cut with a knife. The elements of group 2 of the periodic table are called the alkaline earth metals. These are the elements in group 2: beryllium, magnesium, calcium, strontium, barium, and radium. Group 2 metals are less active than the alkali metals, but are still too reactive to be found in nature in pure form. And as we said that hydrogen has an electron configuration 1s1, but it doesn't share the same properties of the elements of group 1, and hydrogen has unique properties and it's a unique element. And like the group 2, helium has the electron configuration of the noble gas. In spite it has no 8 electrons, it has only 2 electrons because it has only one energy level, which is level 1, which is the K level, and it can be satisfied with 2 electrons. That's why helium is an inert gas. Now let's see this problem together and try to solve it. Without looking at the periodic table, identify the group, period, and block in which the elements that has the electron configuration xenon 6s2 is located. Now first you want to know the group, the period, and the block. First of all, to know the period number, look at the large number beside the symbol. The large number here, the large number is 6, so the period number is 6. To know the group, look at the number of electrons in the last energy sublevel. We have 6s2, so the last one is written s2, so we have 2 electrons, and this is the group number. So the group number is the number of electrons in the last sublevel. And of course, to know the block, look at the symbol, which is S. So this element is found in S block. So to find the period, look at the largest number beside the symbol here. To know the group, look at the number of electrons in the last level. And to know the block, look at the symbol, the last symbol you have written. Now, without looking at the periodic table, another problem. Without looking at the periodic table, write the electron configuration for the group 1 element in the third period. Is this element likely to be more reactive or less reactive than element described in A? Let's first write the electron configuration of group 1. You know, group 1. So the last energy level will have 1 electron. In the third period, so you have the third period. What is the atomic number of the third period? Third period here, the noble gas is neon 10. It's the end of period 2, so we'll have neon. Then we have group number 1, so we have 1 is found in the S block. So let's see the answer here in B. In a third period element, so the highest occupied energy level will be N equals 3, which has 1s, 2s, and 2p sublevels are completely filled. We can call it neon, then 3s1. So you can write it like that, which is the electron configuration, the Aufbau principle, or you can write it in the noble gas notation as we studied before. So this is the electron configuration, neon 3s1. This means that it's found in the third period in subgroup or sublevel S, which is the S block, and only we have 1 electron because it's found in group 1. And now the second part of the question is this element likely to be more reactive or less reactive than the element described in A? The element described in A is found in group 2. See here, this is 2 electrons, so it's in group 2. But here in this problem we found that it's found in group 1. So which is more reactive? As we said, group 1 elements are more reactive than group 2 elements. So because it's in group 1, this element is likely to be more reactive than the element described in A, which is in group 2. Now back to the modern periodic table again. We said that the D block elements are metals with typical metallic properties and are often referred to transition elements. Here in the orange color, the transition elements. The P block elements consist of all the elements of groups 13 to 18 except helium. These are from group 13 to group 18 are all the P block elements except helium. The P block elements together with the S block elements are called the main group elements. So S, the first two groups, with the groups from 13 to 18, all of these S block and P block are called the main group elements. So at its right hand side, the P block includes all the nonmetals except hydrogen and helium, and also we say that metalloids are found in group here are found in pale blue from group 13 to 17 included in the P block. So now comes to group 17, which is called the halogens. These in red, group 17, they are called halogens, and the word halogen in Latin means salt formation or can make salt. We found that these groups group elements, which are group 17 elements, can form salts when they react with metals. They are active nonmetals and can react easily with metals to form salts. So they are called halogens. So these are our sessions for today. Now we will see our class worksheet and try to answer it together. Now, complete each statement below by choosing a term from the following list. Terms may be used more than once. These are some words. You have to pick one word that suits each of these statements. Number 1. The have a single electron in the highest occupied energy level. Who have a single electron in the highest occupied energy level? Someone may say hydrogen, but I'll see here, all of you have. So it's not one atom, it's many elements, many atoms. So what have a single electron in the occupied energy level? Of course they are the alkali metals, the elements of group 1, because as we said, group 1 means contain one electron in their outermost energy level. So number 1 is alkali metals. Number 2, the dash are in the S and P blocks of the periodic table. What are the S and P blocks? As we said, they are the main group elements. The main group elements are the elements of S and P blocks of the periodic table. All of the number 3, all of the dash have 2 valence electron and get to a stable electron configuration by losing 2 electrons. What have 2 electrons in their outermost shell? As we said, they are the alkaline earth metals. The alkaline earth metals. Number 4, unlike the main group elements, each group of the dash doesn't have the identical outer electron configuration. Unlike the main group elements, they are the transition elements, which have different properties than the elements of the metals, which are in group 1 and 2, and also they have different configuration than the elements found in the P block or the non-metals. So unlike the main group elements, each group of the transition metals doesn't have identical outer electron configuration. Number 5, the dash, the most reactive group of non-metal. Before you continue, what are the most reactive group of non-metal? Of course, they are the halogens. The halogens are the most reactive group of non-metal. Number 6, the have a full set of electron in their outermost energy level. What have a full set of electron? They have completely filled outer level. They are, of course, the noble gas. Number 7, the dash are very stable and have low reactivity. Don't forget that we said before that the terms may be used more than once. So what are the very stable elements and which have very low reactivity? Again, they are the noble gas. Number 8, the dash are highly reactive and readily form salt with metal. Who forms salt with metal? And as we said, they are the the halogens. Yes, you are right, the halogens make salt with metal. Number 9, in general, the NOT are metals, or the dash, sorry, are metals that are less reactive than the alkali metals and the alkaline earth metals. They are metals, but not as the alkali metals or the alkaline earth metal. What are the metals in the periodic table except those? They are, of course, the transition metals. So in general, the transition metals are metals that are less reactive than alkali metals and alkaline earth metals. Number 10, the dash are metals that lose one electron when they react with water to form alkaline solution. They lose one electron. They are metals, so they are group 1, which are alkali metals. So the alkali metals are metals that lose one electron when they react with water to form alkaline solution. Number 11, most of elements are metals, because as you can see here in the modern periodic table, group 1, group 2, and from here from group 3 to group 12, all these part, the first two groups and the middle of the periodic table, all of these are metals. So most of the elements are metals. The last question, with its one valence electron react with many other metal. With its one means it's only one element, it's only one atom that have one valence electron, or one electron, which is of course the hydrogen atom. So if you want the answers of this sheet, it's uploaded on the website of the school. You can see them, and here let's see the answers. These are the answers of our classwork sheet number 1. Hope you understand the lesson. Please contact me if there is anything ununderstandable, and till we meet again, goodbye all, love you, and study hard. Bye.